In 1925, Douglas built a military transport that dropped cargo through a trapdoor in the floor, 2,500 pounds at a time. 3 decades later, a Douglas aircraft was swallowing 70-foot Atlas missile stages whole. Between those extremes, Douglas transports and cargo planes reshaped how the U.S. military moved paratroopers, supplies, and heavy armor across the globe. One design in that lineage never left the drawing board. The Douglas C-1 arrived in 1925 as the first American aircraft built specifically for military transport. Unlike earlier planes adapted from bombers or trainers, the C-1 carried a clear mission: to deliver cargo and personnel where roads and rails could not reach. Its most striking feature was a trapdoor set into the floor, designed so ground crews could load or unload up to 2,500 pounds of supplies straight onto the cabin deck. This was a leap beyond what anyone in the Army Air Service had seen. Sergeant William Harris, who flew in those early days, remembered that when they first got the C-1, they were amazed at how quickly they could drop a crate through that trap door, and it saved them hours on the front line. The C-1's cabin could be stripped of seats for freight or outfitted for 6 to 8 passengers. Crews worked from an open cockpit perched ahead of the upper wing, braving wind and engine noise on every flight. In 1926, a fleet of C-1s was dispatched to deliver relief supplies to flood-stricken towns in the Midwest. That trial exposed weak points. The floor flexed under heavy loads, tie-downs slipped, and repeated landings on rough strips battered the airframe. Engineers responded with reinforced beams, extra tie-downs, and rubber-mounted engine mounts to dampen vibration. These fixes, born from field experience, set the pattern for every Douglas transport that followed. Only 26 C-1s were built, but their cargo-centric layout and rapid loading system established the blueprint for airlift thinking, a template that would be scaled up dramatically in the decades ahead. Darkness pressed against the windows as Lieutenant Russell Chandler gripped the controls of his C-47, engines humming low over the French countryside. In the early hours of June 6, 1944, more than 200 C-47 Skytrains carried 13,348 paratroopers toward Normandy. Chandler later recalled, "Imagine being in a formation of unarmed aircraft, dropping below 1,000 feet at 90 miles an hour, with every German in the area shooting at you. Our only defense was darkness and the hand of God." Adapted from the civilian DC-3, the C-47 was built for moments like this. It gained a 42-inch cargo door, a reinforced floor, and a roller system that let crews load jeeps, pallets, and stretchers in minutes. Inside, static line anchor cables ran the length of the cabin, allowing paratroopers to hook up and jump in rapid succession. A T-shaped handle at the door let the loadmaster swing it open at the right instant, sending men and equipment into the night. The same design enabled the C-47 to tow gliders packed with troops and supplies, expanding the reach of airborne assaults. Production ramped up to over 10,200 airframes. By war's end, the C-47 had delivered troops, hauled cargo, evacuated wounded, and dropped supplies on every front. Its ability to switch from cargo hauler to flying ambulance to glider tug made it the backbone of Allied airlift. The Skytrain's combination of ruggedness, adaptability, and sheer numbers proved that tactical air mobility could decide the outcome of a campaign and set the standard for every military transport that followed. The C-54 Skymaster entered the story as a true long-range workhorse, answering a challenge that ground convoys and short-hop transports simply could not meet. When Soviet forces sealed off West Berlin in 1948, the Allies faced a stark choice: give up the city or supply 2 million people entirely by air. The C-54 was the only aircraft with the range, payload, and reliability to keep the airlift going day and night. At the operation's peak, nearly 900 C-54 sorties flew into Berlin every single day, each carrying up to 7 tons of coal, food, or medicine. The pressure on crews and machines was relentless. Mechanics at Rhein Main Airfield set up a so-called cannibalization line, stripping down damaged Skymasters for spare parts to keep others flying. Maintenance teams swapped engines, hydraulic pumps, and generators in record time, sometimes turning around a grounded plane in under 12 hours. Historian Tom Loria described the Berlin airlift as the moment when airlift became a strategic tool, not just a last resort. The C-54 proved that a city could be sustained from the sky, but it also revealed the growing need for aircraft that could carry heavier, bulkier loads in a single trip. That realization would soon drive the design of even larger Douglas transports. In 1945, the Douglas C-74 Globemaster took on a challenge no American transport had faced before, moving truly outsized cargo across thousands of miles in a single flight. Designed from the start as a heavy-lift aircraft, the C-74 could haul up to 45,000 pounds, nearly double the load of its predecessors. Its cavernous cargo bay and reinforced floor made it possible to carry trucks, radar equipment, and even aircraft sections without disassembly. One early mission put these claims to the test. In July 1947, a C-74 departed California loaded with massive radar antennas and diesel generators, bound for Fairbanks, Alaska. The 3,200-mile journey crossed remote, rugged terrain where surface transport was impossible. The aircraft delivered its cargo intact, proving that large, sensitive equipment could be flown directly to isolated outposts. For military planners, this demonstration was a breakthrough. Heavy, complex gear could now be deployed anywhere, not just along established routes. But the C-74's promise came with a cost. Each airframe cost around $1.5 million, and only 14 were built before budget constraints ended production. Still, the C-74 showed that true heavy-lift air transport was not only possible, but essential for the next era of global military operations. A C-124 Globemaster II sits on the tarmac, its clamshell nose doors yawning open as a line of trucks and crates waits to board. Master Sergeant Robert Hernandez, a loadmaster with the 1,501st Air Base Group, stands inside guiding the operation. He remembers the choreography, the overhead crane swinging a bulldozer into the hold, crewmen at the roller floor easing each load into place, every movement timed to the minute. The C-124 could swallow 68,000 pounds at a time. Bridge sections, artillery, even helicopters, making it the largest airlifter of its era. During the Korean War, these aircraft carried entire engineering battalions and vital heavy equipment straight to forward bases, bypassing weeks of overland slog. Hundreds of C-124s form the backbone of the military air transport service, their double-deck interiors and internal hoists redefining what a single sortie could accomplish. Early models faced nose gear cracking under the strain, prompting a retrofit across the fleet, but the basic design endured. The C-124's ability to move outsized loads in bulk, reliably and repeatedly, set a new standard for global military logistics and made it the workhorse of Cold War heavy-lift operations. The C-13 Cargo Master entered service in 1956 with a mission that set it apart from every Douglas transport before it, hauling outsized cargo, especially the massive missile stages of the early intercontinental ballistic missile program. Its cavernous hold and reinforced floor could swallow Atlas and Titan components whole, eliminating the need for time-consuming disassembly. Lieutenant Colonel Ellen Rogers, who flew C-133s out of Travis Air Force Base, recalled, "We were literally moving the nuclear deterrent piece by piece." But this leap in capability came with a cost. Early flight logs recorded a 12% gearbox failure rate, an alarming number for an aircraft tasked with strategic missions. Crews in the field learned to improvise, rigging makeshift brackets and swapping out gearboxes on the ramp to keep missions on schedule. By 1962, after a series of engineering fixes, improved oil cooling, hardened gear teeth, and stricter pre-flight checks, the failure rate fell to 3%. The C-133's reliability was never perfect, but its ability to deliver missile stages directly without rail or ship delays filled a vital Cold War niche. The high cost and constant maintenance demands, though, raised questions about how long the Air Force could keep relying on such a specialized and temperamental giant. Douglas engineers set their sights on a new kind of transport in the mid-1950s, a turboprop giant called the C-132. The plan was bold: build an aircraft that could lift an unprecedented 100,000 pounds of cargo, nearly doubling the capacity of the C-124. Pentagon memos from early 1955 show the Air Force's appetite for this leap, projecting a fleet that could carry tanks, missile components, or entire field hospitals across oceans at 400 miles per hour. But the promise of raw lifting power collided with the realities of cost. By June 1955, a classified memorandum spelled out the problem. The projected unit cost of the C-132 when divided by its payload far outstripped what the Air Force was willing to pay, especially with faster jet-powered transports on the horizon. Congressional hearings questioned whether investing billions in a turboprop made sense as the era of jets began. The program was canceled before a prototype ever flew. What remained was a full-scale mock-up, technical drawings, and a lesson that even the most ambitious engineering can be undone by shifting budgets and changing priorities. The cancellation left a gap in heavy lift capability, but the design work fed into later projects, proving that sometimes the biggest dreams in aviation never leave the drawing board. Military airlift today still relies on principles Douglas pioneered: modular cargo bays, rapid deployment, and global reach. As conflicts and crises demand faster response, the legacy of these designs shapes every mission. Innovation in air transport isn't just history, it's the difference between supply and surrender. Thanks for watching.